Welcome to this short video on medium access control in computer networks. This is Dr. Muthulakshmi, Assistant Professor, Department of Computer Science and IT. Functions of a network is standardized by OSI model in terms of layered architecture. So, OSI model has 7 layers. So, here we are going to discuss about medium access sublayer, which is part of data link layer. Data link layer has 2 sublayers, logical link control sublayer and medium access control sublayer. So, what is the role of this medium access control sublayer? In a broadcast link, multiple stations are connected and they will be transmitting at the same time. So, this medium access control layer takes care of the shared access of the various stations, thereby reducing the conflicts arising between them and reducing the collisions. So, this is possible through the use of multiple access protocols. The multiple access protocols can be categorized as random access protocols, controlled access protocols and channelization protocols. What are these protocols? They are basically network protocols, a set of rules that helps to regulate multiple devices sharing access to the common communication medium. So, in this video we are going to look into the random access protocols bit elaborately. So, Aloha, CSMA, CSMA-CD and CSMA-CA. The first of its kind was pure Aloha. So, before that, what is this random access? In a broadcast link with multiple stations, every station can transmit whenever it has a frame randomly without waiting for other, and each station can compete in an equal way. So, no one is superior, and more than one station when it tries to send, there is a collision. So, we have devised protocols to reduce and avoid collision. The first one of its kind is pure Aloha. In pure Aloha, the stations will send frames randomly whenever they want to send, and what happens here? So, there is a possibility of collision when more than one station tries to send, and here we define what is called vulnerable time, the time during which collision happens. In the case of pure Aloha, the vulnerable time is 2 times TFR. TFR is nothing but time taken to transmit one frame. Okay. So, here the station A transmits, before it completes B starts, and before B completes C starts, with leading to more possible collision during this time frame 2 into TFR. The throughput for Aloha is given here, where S represents the number of successfully transmitted frames and G is nothing but number of frames generated during 1 TFR, and maximum throughput is given as 0.184 when G is equal to half. So, this is a procedure for Aloha. So, in the case of transmission, station which transmits will receive the acknowledgement from the destination indicating that it has received the frame successfully. If it does not receive acknowledgement, then it has to go for retransmission. So, here the letter K indicates the number of retransmissions. So, in the case of Aloha, the number of retransmissions has been restricted to K max, because more number of retransmission will congest the medium. To start with, when a station has a frame to send, initially K is set to 0, it will send the frame and it will wait for a time 2 into TP for acknowledgement. Till that time, if it has not received acknowledgement, it will go for retransmission, it will increment K and it will check whether the K has not exceeded K max, and again it will wait for a back off time which is given by R into TP. R is a random number generated and TP is the propagation time. So, once that time is over, it will go for transmission. So, this is pure Aloha. The improvisation of pure Aloha is slotted Aloha. So, what is the difference in slotted Aloha? The time frame, the timeline is divided into slots. The condition here is each station can send only at the start of the time slot. So, station 1 has started during the first time slot, station 2 and 3 has started during slot 2. So, in between the time slot, no stations can transmit. So, what is the vulnerable time here, the time during which collisions can happen? So, if more than 2 stations are going to start in the same slot, then there is going to be a collision. So, the vulnerable time has reduced to 1 TFR. In pure Aloha, it was 2 times TFR, here it is just TFR. So, again the throughput has improved, the throughput is G into e power minus G. So, when G is equal to 1, the maximum throughput is 0.368, it has doubled. Okay, so, this is the advantage of slotted Aloha. So, in these both these Aloha, there is no sensing of the medium. Stations transmit either randomly or during their slots. So, a new protocol was introduced, that is called carrier sense multiple access, where the stations has to sense the medium before transmitting. So, how does they sense? They are called persistence method. So, there are 3 different persistence method, one persistent, non-persistent and P-persistent. So, in one persistent, the station will keep sensing the medium continuously. When it is idle, then it will transmit, otherwise when it is busy it will continuously sense the medium. In the case of non-persistent, the station will sense the medium. If the medium is busy, it will wait for some time, and after some time it will sense. Once the medium is idle, it will transmit. What is this P persistent? P persistent is a combination of one persistent and non-persistent, where the station will sense the medium continuously when the medium is busy, and once the medium is idle, it will wait for a time slot called the back of time, and then it will transmit. So, it will sense the medium using this persistence method, and then it will do the transmission. So, what is the vulnerable time for this CSMA? So, vulnerable time is nothing but the propagation time. What is propagation time? Propagation time is the time taken for the frame to start and end, to travel from starting point to end point. So, here the vulnerable time is what is the time taken to move from A to D. This is an improvised version of CSMA where the collision is detected. So, this is carrier sense multiple access with collision detection. So, how does it detect collision? It detects collision, the station detects collision based on the energy level in the medium. When there is no transmission, the energy level is 0. When there is transmission, the energy level is normal, and whenever there is collision, the energy level is abnormal. So, what happens here? Station A transmits at time t1 and station C starts its transmission at a bit later time t2 without knowing that station A has already started, because station A's first bit has reached C much later, only at time t3. So, only at time t3 C realizes that there is a collision and it aborts its transmission. Similarly, A realizes that there is a collision at time t4 and aborts its transmission. So, this helps in the station A and C continuing the transmission further. So, this is a procedure for CSMA CD. So, it is almost similar to Aloha. The few differences are, so it includes persistence method, and in the case of pure Aloha, the stations transmit and wait for acknowledgement, but here the stations transmit and keep receiving signals, just checking whether there is any collision. If it is received an acknowledgement, then fine, the transmission is successful. If it detects collision, then it will send a jamming signal over the medium so that all other stations can understand that there is a collision, and finally it will go for retransmission. So, the next improvised version of CSMA is CSMA CA, where it is trying to avoid collision. Here the CA represents collision avoidance. So, the 3 new concepts introduced here are interframe space, contention window, and RTS and CTS packets. What are they? So, here the station will continuously sense the medium. Whenever it finds that the medium is idle, it will wait for a time called interframe space. After that, it will transmit in one of the contention window. Contention window is nothing but time slots. The station will choose randomly one of the contention window and it will transmit. Now, coming to this RTS and CTS, when station A has frames to be transmitted to B, station A has to send RTS packet. What is this RTS packet? Request to send to station B. Station B, after receiving RTS, will wait for a short time called SIFS, short interframe space time, and then it sends CTS. CTS is nothing but clear to send. This CTS packet travels to all other stations in the medium, indicating that station A and B are going to transmit data between each other. So, all these other stations will refrain from sending any data. So, after that A will send all the data whatever it has to send to B, and finally after the completion of data transmission, it waits for a short interframe space and then it transmits acknowledgement. This acknowledgement sent by B will go to all other stations, indicating that the transmission is complete. So, all other stations are free now to contend for the medium. So, this is the improvisation in CSMA CA. So, we have seen all the 4 random access protocols. These are all the 4 protocols which evolved over the time, helps in collision, It cannot completely remove collision, but it will try to avoid collision and detect collision. So, all these are intended to help the stations to access the shared medium in a proper way. Thank you.